All right, we're going to practice the third part of the test, which is Learning Target 6.3. I can use stoichiometry to predict theoretical yields of products in a reaction. The first question, and this is page 5, how many moles of iron oxide, and in this case it is iron 2 oxide, are needed to react completely with 1.2 moles of aluminum? Show your work. So we know that the given amount is 1.2 moles of aluminum. And we want to know how many moles of iron 2 oxide. And so the first step is to have a balanced chemical equation, which they gave us. So I want my moles of aluminum to divide out, and I want moles of iron 2 oxide. And so to find that mole ratio, I look at the balanced chemical equation. There is a 3 in front of iron 2 oxide. There is a 2 in front of aluminum. And then I just take 1.2, I multiply it by 3. Notice the moles of aluminum divide out. 1.2 times 3 divided by 2 is 1.8 moles of iron 2 oxide. I only had 2 significant figures in my given, so I only have 2 significant figures in my answer. Calculate the number of moles of aluminum required to produce 0.75 moles of iron in the following reaction. And look, they have same exact equation, and they balanced it for us. I'm going to start with 0.75 moles of iron because that was my given. I know I need my moles of iron to divide out, and I want moles of aluminum, so I'm going to put moles of aluminum here. I now look at my balanced chemical equation to find my mole ratio. 2 is in front of aluminum. 3 is in front of iron over here. So this is again just a one-step problem. 0.75 times 2, 1.5 divided by 3 is 0.5, and I need 2 significant figures, 0.50 moles of aluminum. All right, next question we have aluminum reacts with sulfuric acid, and they gave us the problem, that's nice, to produce aluminum sulfate and hydrogen gas. First we need to do is balance the reaction. So they gave us the formulas, but we need to balance. I have 1 aluminum here and 2 aluminums here. So in pencil I will put a 2 here. I have 2 hydrogens here and 2 hydrogens there. I have 1 sulfate here and I have 3 sulfates. So I need to have 3 sulfates. Therefore, I need to have 3 hydrogens. So let's double check. I have 2 aluminums. I have 6 hydrogens. And I have 3 sulfates. If it helps to put parentheses around the sulfates so that you can see the polyatomic ion as one single unit. So we're done balancing. Next it says how many liters of hydrogen gas would be formed if I had 25 grams of aluminum that completely reacted with the excess sulfuric acid. I'm going to start with my given 25 grams of aluminum. And aluminum I know has a molar mass of 26.98 grams per mole. I have to turn it into moles before I can do anything. So the first step when you're not given moles to begin with is to turn it to moles, always the first step. The grams of aluminum divide out, and now I have moles of aluminum, and I want to know about hydrogen gas. So I'm going to need to have moles of aluminum divide out. I need to figure out how many moles of hydrogen I have, and again, hydrogen is H2. My balanced chemical equation, I have 3 in front of hydrogen and I have a 2 in front of aluminum, so that's my mole ratio. Now volume, and we're going to say this should have actually said STP. At STP there are 22.4 liters of hydrogen gas for every mole of hydrogen gas. So here moles of aluminum divided out, here moles of hydrogen divided out, And my answer is liters of hydrogen gas. So let's see what we get here. I have 25 times 3 times 22.4, and I divide that by 26.98, divided by 2, and I get 31.13. I have 3 significant figures, so I will just say 31.1 liters of hydrogen gas. That's 31.1 liters. Okay? That is it for page 5.